Welcome to the deep dive. Look, if you're still just, throwing simple chat prompts at your AI, hoping for the best, you're really missing out, leaving huge efficiency gains just sitting there.
Yeah, absolutely. Today we want to cut through some of that noise.
We're aiming to help you build a proper, strategic AI infrastructure, something that actually scales.
Right. Our mission today is basically to take you from being just a basic prompt user more towards being an architectural planner for your AI.
We're diving deep into the framework that can turn AI from, I guess, a helpful suggestion box into more of a reliable, even autonomous business partner.
And we've pulled together a whole stack of sources, everything from, basic prompt discipline right up to the really cutting-edge stuff on model orchestration.
So we're planning to unlock this whole process for you. We see it in about 3 key steps. First up, nailing the master prompt method, getting that consistency.
Exactly. Then second, defining and maintaining those specialized AI agents, you might know them as custom GPTs.
And finally, getting into the efficiency side of things. Mastering how you organize it all with mixture of experts architecture.
This whole infrastructure, this is how you make your AI predictable, reliable. And we have to start at the foundation, defining the AI's identity, making it persistent. And that means really understanding this master prompt method.
Okay, let's unpack that then, because I think a lot of people think they know prompting, but what really separates just a one-off question from what you're calling a master prompt?
That's a great question.
And I guess, does building this super detailed, comprehensive instruction set, does it actually cost more? Use more tokens, slow things down?
Yeah, okay, so that's the strategic trade-off, right? A master prompt isn't just a question, it's a persistent set of instructions. Think of it like a really thorough job description for the AI.
Okay.
So yes, you might use slightly more tokens, maybe it's fractionally slower up front, but the payoff is huge. You're basically guaranteeing high-quality, consistent output every single time. It defines how the AI should behave, how it thinks, how it responds consistently.
Got it. So it's really an investment up front for that consistency down the line. I noticed the sources really hammer on a specific structure for this. Role, objective, task, context, format, tone, and boundaries. Yeah. Why are those first and last ones, role and boundaries, so critical?
Right. Well, defining the role is huge because it helps the model tap into specialized knowledge. And it's linguistic style, too. If you tell it you are a senior marketing strategist, it draws on a completely different data set than if you just say, give me some ideas.
That makes sense.
And defining the boundaries is just as vital. It sets the guardrails and makes sure the output stays within specific limits, maybe legal, ethical, or just word count. That really cuts down on the need for a human to go back and fix it later.
Okay, could you give us a quick concrete example? Like, how much better is the output, really, when you use this full structure?
Sure. So instead of something vague like, write a memo, a master prompt gets specific using that structure. You are a senior compliance officer, role, analyzing a new privacy law context. Your task is to provide a summary of 3 key actionable changes for our engineering team. Objective task. Use 5 concise bullet points, format, and maintain a formal but urgent tone boundaries. See the difference?
Yeah, absolutely. That precision, it must save a ton of back and forth, right?
Exactly. It drastically reduces revision time.
So the path to getting these master prompts sounds like it's all about iterating. You tweak it, you test it, find what works best, and then you kind of lock in that winning version.
Precisely.
But okay, once you have that perfect prompt, that golden ticket, how do you stop the team from just losing it? Or worse, everyone constantly reinventing the wheel?
Yeah, the classic problem. That's where a prompt library comes in. And this isn't just like a shared Google Doc. It needs to be treated as centralizing your intellectual property around AI interaction. It's absolutely crucial for version control. You need to know if you're using v1.0 or v1.1 of a prompt. And it stops that knowledge loss. Without it, your best prompts just vanish into people's private chat histories. Everyone starts from zero again and again.
Okay, a library makes sense. But I can see how if a team builds up, say, hundreds of these optimized prompts, just finding the right one could become a nightmare. Should we organize them by department, maybe? Like HR prompts, finance prompts?
You could do it by function or discipline. It's possible. But the sources we looked at really lean towards a task-based system for organizing them.
Task-based. Why is that better?
Because it lines up much better with how people actually work, focusing on the outcome. When you organize by task, let's say, the task is generate quarterly earnings report insights. The library becomes more like a prompt playbook.
I see.
It can link multiple steps together. So for that earnings report, you might have prompts for analyze raw data, then summarize key findings, then draft executive bullet points. They're all related to the same task, accessible together.
That makes immediate sense.
Yeah.
Our teams don't just summarize things in a vacuum. They summarize for something specific.
Exactly. And to make that library truly usable day to day, you absolutely need good metadata. Make it searchable. Things like use cases, category or tag, version number, and this is important, the status.
Status, like approved or in progress.
Yeah, or even just draft versus optimized. Having a draft status is great because it encourages people to contribute ideas without feeling like they need a perfectly polished prompt right away. It makes the library feel more collaborative, less like some bureaucratic chore.
Good point. Okay, so the library is organized, it's searchable. But what about those moments when I need that complex, perfectly crafted prompt right now? Any tricks for quick reuse?
Oh yeah, definitely. You should absolutely leverage text expanders or even simple browser extensions. Tools like Raycast, Alfred, Espanso. There are lots of them.
Text expanders.
Yeah.
Like shortcuts.
Exactly. You set it up so you can type, say, earnings, and boom, that entire multi-line master prompt for the earnings report analysis just appears. That kind of quick access is absolutely essential if you want people to actually adopt using the library.
Okay, so we've established this persistent, high-quality AI identity using the master prompt and the library. But like you said, even a perfect prompt, it's still reactive, right? You have to tell it what to do each time. And that kind of hits a wall if we need the AI to be more proactive, to take initiative. Is that why we need to move beyond just prompting towards these specialized agents?
That's precisely the reason. An AI agent is fundamentally different from just automating a task. It's actual software that, well, it observes its environment, it makes decisions based on that, and then it acts, often without needing constant hand-holding from a human. And crucially, it learns and adapts as it goes. Traditional automation, it just follows strict if-then rules. An agent can reason.
And the brain inside that agent, that's often something powerful like GPT-4.
Very often, yes.
For someone listening who maybe doesn't track all the machine learning jargon, what's the simplest way to think about how that self-attention mechanism helps an agent be better? Better at remembering context or making decisions?
Okay, good question. Think of self-attention like the agent having really good selective hearing or reading skills. Imagine it's looking at a super long conversation or a big document.
Right.
Instead of having to reread every single word equally to find something you mentioned last week, self-attention lets it instantly know which parts are most important for the current question. It highlights the key bits. It knows where to focus its attention to pick up the thread of the conversation, even after days. That's why models like GPT-4 are so good at holding context and reasoning through complex stuff over longer periods.
Oh, that makes perfect sense, like finding the right page in your notes instantly. So practically then, how do we actually go about building one of these custom agents?
You have to start by defining a really sharp scope. Give it a clear, specific purpose and role. Not just a researcher, but maybe a specialized legal researcher focused only on EU data compliance updates.
Okay, super specific.
Yeah, the sources really emphasize this. The tighter you make the scope, generally the faster you can develop the agent and the better it will be at that one specific thing. Then you use tools like OpenAI's custom GPTs or frameworks like Semantic Kernel or LangChain.
Yeah.
These let you embed its specific instructions, its memory, the tools it can use, its required style, right into its core system prompt.
So that defines the brains of the agent. You said an agent needs to act. It needs hands to actually do things in the real world. If ChatGPT itself can't just decide to send an email for me or update my CRM, how does the agent bridge that gap?
That is the absolute critical step. The core AI model, like GPT-4, provides the intelligence, the brain. But to become a true proactive agent, it has to be connected to the outside world.
Through APIs and things.
Exactly. You need to wire it up, give it access to APIs for your CRM, your calendar, databases, whatever tools it needs to actually execute tasks. And importantly, you usually need to build some kind of external memory layer too, something to help it maintain long-term context that goes way beyond what fits in a standard chat window.
So like an agent that's supposed to qualify leads needs that API connection to the sales database so it can actually change the lead status itself from cold to hot, for instance.
Precisely. That's the action part. And maintaining the agent's specialized skill, it's nuance. That requires constant attention. You store its core context in those system prompts, yes, but you also need a continuous feedback loop. You have to relentlessly test it.
How do you test it effectively?
You simulate failures. You feed it weird, unexpected inputs. You need to see how it recovers, if it stays on track, if it maintains that specialized behavior over time, even when things go wrong. It's ongoing refinement.
Okay, so we've built our single, powerful, specialized AI teammate. But here's where the scaling question really bites, right? If having one specialized agent is great, managing 10 or 20 or 50 agents for all different kinds of tasks sounds like an absolute organizational
Oh,
nightmare.
absolutely. It would be.
Which I assume brings us to this next level of architecture, the mixture of experts, or MOE.
Exactly. MOE is this really elegant, highly efficient, and scalable architecture that's basically designed to solve that exact management problem. The core idea is this. Instead of firing up one gigantic monolithic AI network every single time you have a task, which is computationally very expensive.
It uses a lot of power.
Yeah. MOE intelligently routes that specific task to only a few smaller, specialized submodels. Those are the experts.
Okay, wait. So we get the smarts, the knowledge base of a giant model, but we're only actually paying the computational cost, the energy cost, of running a couple of smaller ones each time.
That is the fundamental concept. It's called conditional computation. You get the representational power, the knowledge of a truly massive model, but you only activate and pay for the computational power of the specific experts that are relevant to the current task. This is a huge reason why these massive language models can even exist and scale to trillions of parameters today while still being somewhat efficient for practical use.
That sounds like you need a pretty sophisticated air traffic controller, I guess. If the experts are the specialized submodels, what's doing the routing? How does it know which ones to send the task to?
That's the job of the gating network. It essentially acts as that intelligent router. When an input, like your prompt or query, comes in, the gating network examines it. Then it uses a strategy, often called a top K routing strategy.
Sorry, top K. What does the K stand for there?
Good question. K just represents a small number. So top K routing means the gating network selects, say, the best two, K2, or the best three, K3 experts it thinks are most suited for this specific input. It activates only those experts and usually assigns weights to how much each of their outputs should contribute to the final combined answer.
Okay, that makes sense. But hang on. If the gating network figures out that, say, expert 3 and expert 7 are generally the best performers overall, won't it just start sending everything to them? Won't it get lazy and just rely on its favorites, meaning the other experts never get used or properly trained?
That is a major potential pitfall. It's often called the lazy router problem or expert imbalance. And MOE systems have a specific mechanism to fight against this. It's a really crucial feature called load balancing loss.
Load balancing loss. Okay.
Yeah, it's basically an extra auxiliary calculation that runs alongside the main training process. Its whole job is to penalize the system if the workload isn't spread out reasonably evenly across all the available experts. It actively encourages the router to utilize the full diversity of specialists, even if some aren't the absolute #1 top performer for every single task. It ensures they all get trained and stay useful.
Wow. Okay. That sounds like a small technical detail, but it probably changes everything when it comes to actually making MOE work at scale.
It's absolutely critical for practical implementation, yes.
So taking that MOE concept, this idea of having specialized experts that can be activated in parallel, how does that fit into the bigger picture, these broader patterns of organizing multiple AI agents?
Well, MOE as a technique is almost the perfect technical underpinning for what we call the concurrent orchestration pattern in multi-agent systems.
Concurrent orchestration.
Yeah. In concurrent orchestration, the idea is you run multiple different agents simultaneously on the exact same task. The goal isn't to pass work along a chain, but to get diverse, independent analyses of the same problem all at the same time.
Ah, okay. Like that example you mentioned earlier, the financial firm looking at a stock. They don't run the analysis one after the other sequentially.
Exactly right. They might have 4 specialized agents. Maybe one for fundamental analysis, one for technical chart patterns, one for market sentiment, and one for ESG factors. They all analyze the same stock in parallel. Bang! You get 4 independent viewpoints almost instantly, which a manager agent or a human can then synthesize for a really fast, well-rounded investment decision. That's concurrent. High-speed, diverse output on one task.
Got it. And that's obviously very different from the more traditional sort of step-by-step process.
Right.
What you call sequential orchestration.
Yes, exactly. Sequential orchestration is much more like a traditional assembly line or pipeline. One agent does its job, and its output becomes the direct input for the very next agent in the chain. Think of that law firm contract process example.
Right, the template selection has to happen first.
It must happen before clause customization can start, which must happen before the regulatory compliance check. The flow is linear, it's deterministic. Each step depends on the previous one being completed.
Okay, so we've really covered the whole stack then. We started with locking down that persistent AI identity using the master prompt and a library. Then we moved to building the specialized self-aware teammate with the custom agent, focusing on its scope and its hands. And now we've seen how MOE provides this efficient system for managing lots of those specialists, especially in that concurrent pattern.
So what does this all add up to? What does this whole stack mean for the future, for getting towards truly autonomous AI problem solving? Yeah, I think it means we're really starting to move into an era where AI systems can manage ambiguity much better. We've talked about these deterministic sequential flows and these parallel concurrent flows, but what about the really complex, messy, open-ended problems, the ones where you don't even know the right sequence of steps up front?
Right, where the path isn't clear.
Exactly. For those kinds of challenges, there's one final, even more advanced orchestration pattern that's emerging. It's sometimes called Magentic orchestration.
Agentic orchestration. Okay, that sounds almost biological or something.
It kind of is in its adaptability.
Yeah.
In a Magentic system, you have a manager agent, but it doesn't just follow a predefined script or workflow. Instead, it dynamically builds and refines what's called a task ledger.
The task ledger.
Think of it like a real-time evolving plan of attack. The manager agent creates this plan through constant back and forth collaboration, negotiation with all its specialized agents. It iterates, it might backtrack if something doesn't work, it delegates new tasks on the fly. It can even rewrite parts of its own plan mid-execution based on new information. It figures out how to solve the problem as it goes.
So the AI isn't just executing a plan someone gave it anymore. It's acting more like a lead architect or a senior project manager who has to adapt when unexpected problems crop up during a big project.
That's a perfect analogy, precisely. And this capability, this shift, it fundamentally changes AI from being just a tool that answers our questions to potentially being a system that can design, plan, and execute the entire strategic approach to solving a complex problem itself. Think about how a really good site reliability engineering team dynamically handles a major system outage. They don't follow a simple checklist. They diagnose, plan, delegate, and adapt in real time. So the provocative thought to leave you with is this. If an AI system can design its own approach to solving novel, complex problems, what kinds of huge business challenges or scientific problems that are currently bottlenecked by human cognitive capacity or coordination limits suddenly become tractable? That emergent adaptive planning capability, that's the future direction you should really be exploring next.
That is a truly phenomenal place to leave it. Thinking about AI not just as an answer engine, but as a problem-solving architect. Thank you so much for guiding us through this whole architectural stack, from prompts to agents to orchestration required to build genuinely more autonomous and effective AI workflows.
My pleasure. It's a fascinating space, and it's moving incredibly fast.